Okay, so one of the things that goes along with congruent triangles is this theorem called Cpctc. And that stands for corresponding parts of congruent triangles are congruent. It's kind of the theorem in itself. Corresponding parts, so the parts of congruent triangles are congruent. So you remember how we had to have all 6 parts congruent before we could prove triangles congruent? And then we had the shortcuts. We had side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse, leg. Those were all kind of shortcuts that told me I only needed about 3 of the parts to prove triangles were congruent instead of all 6. Well, now that I have triangles are congruent by one of those 5 theorems, then I can go back and say, okay, well, if my triangles are congruent, then all of the parts are congruent. So that's what this theorem says. Corresponding parts of congruent triangles are congruent. So if I take a look at my example here, it tells me angle IEF is congruent to triangle HGF. So at some point in time, they've already been marked congruent. Okay, and I want to find A. A is angle H. So here's angle H. It's the first angle listed. So that corresponding part is going to be the first letter listed here, I. So I and H correspond. And since I already know the triangles are congruent, and I see angle I is 35, well, that means A is also 35 degrees. And that's because the triangles are already congruent. That means all the corresponding parts are congruent as well. So if I move to example 2, triangle PQR is congruent to triangle MNR. Okay, well, if I want to try and find where angle R is, that corresponding part is angle R as well. So that's that vertical angle theorem that we have. So this angle is congruent to this angle. Well, I don't have that angle over here. What I do have is a 90-degree angle and a 38-degree angle. Well, I can find what angle R is. I can use, it's kind of like the triangle sum theorem, but we have a theorem that says in a right triangle, the 2 acute angles add up to 90. So I could do 90 minus 38, and it's kind of like I'm already subtracting this 90 from 180. But the acute angles in a right triangle do add up to 90. So that tells me that's 52 degrees. So I can find that using triangle sum theorem. That's 52 degrees, and because it's vertical and because it corresponds, then I know X is also 52 degrees as well. Okay. And here we have another example. Triangle ABD is congruent to triangle CDB. Find X. Okay, so, well, X is at angle, and this is a D, it got kind of cut off. Angle ADB. Okay, angle ADB. So I went A first, D second, B third. Okay, well, that corresponds, let's see, I'd have to go C first, B second, and D third. That is CBD. Okay, so that these 2 correspond. Okay, so if they correspond, then that means they're congruent. So 4x minus 31 would equal 2x plus 11. Okay, and that's because they are corresponding angles. They are the same angle in both triangles. So then I just solve for x. So I'm going to subtract 2x from both sides. And I get 2x minus 31 equals 11. And then I'm going to add 31 to continue to isolate x. That eliminates, and I get 2x is equal to 42. Then I divide by 2, and x is equal to 21. Okay. Okay, so then that comes back into that algebra property. So the geometry was the fact that 4x minus 31 and 2x plus 11 were corresponding angles in congruent triangles. That's that core Cpctc. Those corresponding parts were congruent because the triangles were congruent. Then I set it up algebraically and solved for x. Okay, we are now done with congruent triangles.